Hello my friends and greetings from Germany. This is going to be my first video and it's about 8 inches per mile squared. People keep on asking me if this formula is correct to calculate the Earth curvature, and even more people keep telling me that it is not. So I just thought I'm gonna make a video about that. I wanted to make a meme, but you cannot explain that in a meme. I would need dozens. So I just thought I'd make a video. Please excuse the bad language, and I do not have a very expensive camera, and I do not have a $50 million a day budget like NASA does. So I have to hold the camera in one hand and point at things and do stuff on my computer to show you with the other hand. So please excuse the bad quality. So 8 inches per mile squared. How do we calculate? How do we calculate the Earth curvature? And that is not very difficult because probably most of you have had that in school. So this is Earth. It's a ball, as you can see. Nice one. Earth, right there. So, and you see this triangle there. Okay? Now, let me show you something. This triangle is called, I cannot pronounce that, so
isosceles triangle.
Right.
Isosceles triangle.
What? This kind of triangle. Okay. To calculate, if you have A and B, you can calculate C. Now, if this is Earth and this is the center of Earth, we know the radius of Earth. Okay, the radius of Earth, you can Google that. Google says 3,963. Wikipedia says 3,959. Other websites that say it's 3,958. Let's just say this is an average of 3,960 miles radius of Earth. Alright, so A, right here, A is 3,960 on average. And if you want to calculate, we know B as well, so we can calculate C. How do we do that? Okay, there comes Pythagoras. I probably pronounced that wrong as well. In German you say Pythagoras. Okay, so we all know that if you want to calculate, it's A squared plus B squared equals C squared. Following that, C squared must be equals A squared plus B squared. And following that simple math, it's C equals the, what do you call that? I forgot. Square root of A squared plus B squared. Alright. So, since we know the radius and the distance, we now can calculate how long this is. But actually, we are not interested in C, because C goes from here all the way there. We don't need C. What we do need is H. I call it H because it's the height, the target hidden height. But since this part from here to the center is A, we just need to take C right up there. C minus A must be H. Alright? If I have C and I subtract A from it, the result is H. Okay, now I'm going to show you something. We're going to do this together. This is a picture taken from Michigan. I think the place is called Stevensville in Michigan. And you have a great view all the way across the lake. And what you see is the skyline of Chicago, which I believe is in Illinois? I don't know. Anyway, Google helps us here as well. Okay, right up there you see Stephenville in Michigan. There's the big lake, and all the way across there's Chicago with its skyline. So Google Maps says, and I hope you can read that, it says 57 and something miles distance all the way across the lake, right? So then I was looking for something else. No, let's calculate first. We need a calculator. Wait, right here. So we do know what we have to do is taking the square root of a squared plus b squared. So a squared is our radius of Earth, which, remember, is an average of 3,960 miles. So 3,960 times 3,960. Oh, wait, we forgot this. So 3,960 times 3,960 plus b squared, and b squared, remember, is the distance we are watching, which is, I hope you can remember, wait a second, I'm going to show you, right across the lake, 57 miles. So let's get back to the calculator, and what we have to do is plus 57 times 57 equals. So this number might look familiar to you. 3,960.410200603. This is our C right there. But remember, we do not want C. What we do want is H, so we have to subtract from the C the A, the radius of Earth. I'm going to do this now. So minus 3,960 for the radius of Earth, and what we get is H, and this is the target hidden height in miles. But as always, we do not want miles, we prefer feet. So miles to feet, and I did that already, 0.4102. I just took the 4 first digits after the 0. That is 2,165 feet of curvature. Alright? So I noticed that here, 2,165 feet. So now the problem I have here is, and maybe someone explain this to me, this building, these are the buildings on the Chicago skyline, and the tallest one is one that is called the Willis Tower. I believe it used to be the Sears Tower, today it's the Willis Tower. And the Willis Tower is roughly 525 meters high. Now I know that most of you probably do not much about meters, so we need to calculate that into feet. 525 meters are equal 1,722 feet. So this highest building in Chicago is 1,722 feet high. I wrote that down here as well, 1,722, and right next to it 2,165 feet of curvature. Now I am wondering if we have an approximate curvature of 2,165 feet. How can a building 400 feet smaller than that be totally seen? Right there. Right there. You even see the antennas up there. Look. Antennas up there. Okay, they all have antennas. But I'm pretty sure, yeah, that is the tallest one right there. This is the Sears Tower, and you can see all of it, all the way to the bottom. well, something is missing. Now, you might wonder, we were talking about 8 inches per mile square, right? And you might say, well, we didn't calculate with 8 inches per mile square. So what I'm going to show you now is an earth curve calculator, and they usually use 8 inches per mile square. And if you have 57 miles right there, target distance 57 miles, right? And you calculate that, then you have 1,944 feet. That is not much of a difference, if you ask me. Oh wait, we have to put something in there. Must be sequence of digits of at most. Okay, let's say we put there in there as 0. He wants something. Oh, and it's it's the same. See? Okay. Eyesight 0, 57 miles target distance. Then it says 2,166 feet. What we calculated was 2,165 feet. Just 1 feet of difference. Okay? But usually someone might say, well, you're not looking from the bottom, you stand up. Okay, how tall are you? 6 feet? Okay, 6 feet eye height, and that would be 1,944 feet. So the taller you are, the less target hidden height you get. You know, if you climb up on a mountain, you probably can look further. Makes sense. What we did here was, of course, without any height. It's like you stand right here, you know, like an ant. Not much height. You're very, very small. So, as you can see, using simple math, Pythagoras, and using 8 inches per mile square doesn't make any difference. You always get the same result. And I'm going to show you something else. If you just calculate it with 8 inches per mile square, you can do this as well. 57 miles square times 57 equals this times 8 inches is so many inches. And now we have to think how much that might be in feet, which I don't really know right now, but wait. Feet, we can get this meter. Okay, feet in, no, inches, we need inches. Inches to feet. There we get inches to feet. And put it in there. 2,166, 2,165. See? 8 inches per mile square. You can use the calculator online. You can use just 8 inches per mile square, or you can draw something and do your own calculation with Pythagoras. You always get the same, and it's correct. So, I hope you enjoyed that. It's not really that difficult. 8 inches per mile square. If there was a curvature at all, we would definitely be able to see that. Just drive to Michigan, ask Johnny Perry if you want to. He will take you there to the beach and have a look at the beautiful skyline of Chicago. Greetings from Germany. Have a nice day. Hope you enjoyed that. Bye bye.